Okay, yeah, it's past time. Let me go ahead and start. Uh, okay, good morning. So in case anybody's watching this after the fact, so I think the recordings have been coming up okay for these live sessions. So let me go ahead and just remind people where we're at. Some announcements at the top here, and then we'll get into things. So don't forget, we do have an assignment. There's actually two things for this Friday. I'm looking for you guys to have accepted the class project, the final project, and have selected a data set that you're going to work on. So make certain you've done that. Make sure you've made at least one commit where you've modified the README on that, and you specified which data set you're looking to do. I'm going to try to look over those here and check, make certain there's none that would be problematic to use as soon as like this weekend or something. So, and there is assignment 2. So both of those, I mean, there's still people that haven't accepted stuff. And I had a question. So I think I brought this up before. When you accept these assignments, some people get a preliminary error message from GitHub when it tries to create the repository, and it's happening to lots of people. So just remember, I always just email back to them, check your email. So it seems that GitHub workflows, this GitHub Classroom has changed their workflow a little bit. So you have to do some sort of a positive action to accept and be granted access to the repository for most people for now.
Yeah,
So
it's issue for those who has like primary email address and yes, like university email address. So what I usually do is I go to my settings and change my email address to the university email address. Then I can accept the invitation.
Okay. So I think that it would send it to whatever the email address is that you've set on GitHub. So I don't know why you'd have to change your email address.
Oh no, like one is my personal email address,
Right.
and another one is university.
Right.
So
I think whatever email is set on GitHub is where it's going to send the confirmation email. But I could be wrong because I'm not experiencing
I
that.
think because of the school's like security features, because of the new email, because I think it might be because they changed the email. So if they use, we still have old. Because I had this problem where if I try to email a professor who's using the new email, but I'm still using the C email. It would tell me this is an external like company,
Yeah.
and I should be careful for email. So maybe they have a new like security on
Yeah.
the emails, so it might register differently depending on who's keeping who.
Okay, yeah. So, but yeah, I'm not 100% certain what the issue is for these GitHub Classroom creations, but check that. If that doesn't work, you should be able to also, it should show up in your organization. So I'll just remind that real quickly. So I usually access my repositories that are being set for these GitHub Classrooms by going to my GitHub actual account and checking my organization. So you should be a member of the 574 Spring 2026 organization. And if you look in there, you should be able to find your repositories, including ones that need that final step. So, yeah, most likely you won't be a member of a lot of other organizations, just this class or one or two others if you've been taking stuff from like deep learning or something. But yeah, you should see it in here. Just the repositories you'd accept it. And yeah, if you're having problems with that, also, if people watch this after the fact, there usually appears a link here or a button here to do the final acceptance. So you can check that out too. But yeah, and as I started saying though, so I did have one or two people like yesterday saying they were having that issue. So it might be a little bit late to be accepting stuff just a day or two before things are done. So, just a reminder on that technical issues aren't really excuse for being late on assignments. So it would be a good idea to, like for example, as soon as you finish the assignment 2, you might want to go ahead and accept assignment 3, like this weekend or Monday or something of next week, just to make certain that you have your repository created, and also check that your container can be created. You can run notebooks, that kind of stuff. I mean, make certain that you at least have everything ready to be able to write code and do the tasks early, just in case, because technical issues do come up. Like this, a lot of people are having this that slows them down to get their repository created for them, but other stuff can happen. You end up with issues with your Docker containers. You want to leave yourself time to make certain that you at least have the basic stuff running, so that you can actually work on the assignment tasks and things in a timely manner. So, okay. But yeah, hopefully, I keep nudging people on that, but hopefully they'll be able to access stuff and can get their assignment 2s in timely manner here. Even if you start just working on it yesterday, if you haven't accepted yet, you really probably should do it as soon as possible and get started on things. So, okay. So with that in mind, I am going to continue on where we left off. I was going to just explicitly bring up the assignment 2 here, see if anybody here or, I've got somebody join me online. If anybody has an explicit question that they're working on assignment 2, there's 1 or 2 things I want to discuss on that, like the thing about creating the decision boundary. So I might jump to that first here. And then if we have time, I'll maybe go back and talk about classification. So the materials from the chapter in our textbook that you should have been looking at this week as well, and watching the videos of our walkthrough of that kind of stuff. And kind of a reminder, looking forward here, we're going to get into the details of doing linear regression next week. And another assignment, we actually kind of got 2 assignments on doing regression problems. So we'll do one where we actually build the basics of a linear regression and do gradient descent by hand. That'll be our next assignment. And then after that, we'll do something a little bit more advanced with polynomial regression. Yeah, and because of our delayed kind of start, our midterm exam, I'm going to check my dates here. It's going to be, I usually like that to be before the spring break, but it's probably like our spring break, so we'll probably have to move some stuff around there or check out our dates. But yeah, we might be having our first test kind of after the week after the spring break, which is not great, but that might be where we'll land with stuff. So.
Professor, this midterm exam, is it going to be in person or online?
It'll be online. It'll be a online quiz, so since people are asking about it, we'll still have a little bit of time before that, but it'll be a mildly online quiz, but it'll be more similar to our assignments for the class. So there'll be like a set of questions and like an empty IPython notebook, and it'll have a time limit. So that's the only difference. That's the difference between kind of the assignments and the exam. So you have a 2-hour time limit, but you'll get some questions. You'll be expected to answer the questions in the IPython notebook and attach the IPython notebook as your work for the but yeah, it will be online. There'll be like a few days where you can start the attempt on it. Probably like Thursday, Friday, or Wednesday, Thursday, Friday. But I will talk more about that. But yeah, they will be online, so people will be able to do that. Won't have to come to class to do exams. Okay. So, like I was planning, I think I'm going to start with. I'm just going to bring up. I haven't really looked specifically at the assignment 2 questions. We were kind of discussing the general things on Tuesday, but we were looking at the notebook in the 574 repository that was sort of an overview of using scikit-learn and using stats model. So hopefully that's a resource that's useful for people. But yeah, already have the assignment 2 here and running a container. So I don't know if I need to remind people at this point about how to get this kind of stuff. This assignment and the future ones, I think. Hopefully, I forgot to check the assignment 3 here, even though I just posted. I'll try and check this as soon as I can to make certain that we had this. But yeah, it should be set up so you don't need the token. Hopefully, the Python path is all set up, but I'll kind of remind people on that. So when it starts up your Jupyter Web server, if you're using the web-based, you just need to add in these flags in order to set it up so it won't require a token or a password in order to get into it. Another good thing to check would be that our Python path should be working, should be set up. So it should be set to be workspaces, the main, your repository, which will have your GitHub user ID, your GitHub username, depending on there. And yeah, and then source. So that's where the Python files that we try to import at various places are in there. So if that's on your Python path, it should make things right, including, I don't know if I've shown this before, but there was one other note I was going to make for people watching this, is that before I was trying to show running these tests here. So it should be set up, you can actually run the tests for the assignments from in VS Code, but that might not be showing up initially. It probably should show up, so it should configure and automatically find these Python unit tests, but it doesn't seem to do that, so I got to check the configuration again still for the assignments. But I did find that if you just open up a notebook in VS Code, so like if you go and open up your IPython notebook, and you do need to select a kernel. A reminder about that. I mean, it's perfectly fine to also use the built-in ability of VS Code to run your notebook. So it knows how to do these and how to actually run cells. So it's not just an editor. It is a notebook. You can edit and execute cells and things. You do need to make sure you have the right kernel selected. So the very first time you do that, it doesn't seem to be selecting a kernel here. So on the upper right hand, one way to do that, you could look at your command palette, but also you can just click on there to specify a particular kernel. Make certain that you are using the one in the opconda bin Python. So that is the one that's installed in these dev containers. So we're expecting that particular version of Python and the particular correct versions of all the libraries that we use. Right. So there are probably other Pythons available. So some of these are just installed in the basic operating system. So it's a 3.11, 3.11 version in bin and user bin. It's probably the same thing there. But yeah, you might have problems if you select that one when you're doing running your kernel. So you should, if you are running these dev containers, you should find that there's this one in the opconda. We use the conda package manager, and it installs a version of Python there, and that's the one that's expected for the tests on GitHub, and all the versions and stuff are pinned to that particular Python version kernel. So yeah, if you select that, you should be able to run your notebooks inside VS Code. If you like it better, you can do that from there. But also that should make it so that you can run the test there. So once you've done that, you should find that if you look at the testing, you'll see it here a lot or not, but if you look at the testing, you should find that you can run your unit tests from here, although none might be set initially, or for these assignments, I do set them up so that you can always do stuff from the command line. So if you don't open up a terminal, you should be able to run the unit test. I mean, they'll all be failing, but if you haven't completed any tasks there, but you can run basically the same tests you need to pass through some tasks. You can try them from VS Code there. So I think that's not working either. So So I'm going to show that, but so yeah, there might be some more stuff we have to get figured out there. It might not. It might be that not until you actually get like one of the tasks passing. But I'll look for that some more. But some people might find that useful to, you can always run the notebooks. They should be running the tests that you need to pass, but you can more quickly get a summary of all the tests that need to pass by coming in here and running the command line. Hopefully, you should be able to do it from there too. Everything's set up correctly. The built-in test runner GUI in VS Code here. Yeah, so I'm going to go ahead and close this notebook here because it's not a good idea to have the any file, but to have these notebooks open up in two different places. You might get problems if you switch back and forth between making edits in VS Code and running the notebook on your Jupyter Lab server and making edits on there. So I'll just close that off. I usually like to run the stuff personally on web-based version. So when those passwords are set up, you should be able to do, you don't have to go to that no-hub file anymore. You can just do a control click. Should be able to get into your Jupyter Lab running on your host system's browser using that forward port 8888. Access stuff. So let me make sure that this is everything's running on this. So that's what I usually do when I'm doing these assignments or asking or recommend people to do when you first come up. I mean, these all should run. So every cell, if you go all the way down to the bottom, it actually runs these. So there's like 42 code cells here. Every one of them, a lot of them are just empty or comments. It is actually running these cells here, although it might look like it's not. It's running a test, just the tests aren't passing. So, but that's expected until you actually implement the described code there for those tasks and get those passed. Okay. So let me know if anybody had any specific questions about stuff on the assignment that are here. I'll talk more about the exam later. So somebody online was asking a question about the exam. So we've got a couple of weeks before the exam is coming up. It is going to be online, so that's usually the kind of main question I think people have. So just to repeat on that, it will be delivered through D2L using the quizzes, tests, online functions. But we'll talk more about the tests as we get closer to it.
So it'll be MCQs?
What's that?
Will it be multiple choice questions?
No. It will. I'll give you some questions, and there'll be an empty IPython notebook. It'll be timed, but you'll have to write some IPython code and update the IPython notebook, or upload it to submit your answer. All right. Another reminder, don't forget that on this assignment, and probably most all the future ones, I mean, there is stuff you actually have to do in the notebook. So, the score for the assignment isn't just getting the functions in the assignment tasks written and passing the test, but to also do the steps in the notebook. So this are meant just as some practice for like loading data and doing a little bit of exploration and cleaning and some visualization. So you are asked to just create a scatter plot showing the raw data and the data after you fit your model. As a hint here, so I don't remember if I described it a lot in the notebook here. So, but when you're asked to replot this, where you show your visualization of your fitted linear regression, the what I'm looking for, and I'm hoping people will do, is use the slope and the intercept parameter. So if you have the slope and the intercept parameters, that defines a line here, right? If you remember, markers here. So, I mean, just given, so since we're having just a single feature where we're doing this linear regression here, we can visualize that as a line. And all you need is the slope and the intercept. And given that, you can plot what the fitted line is. And basically, the slope, what we call the parameter, so there would be one parameter, which I'm calling the slope here, which would be m, and then the intercept would be the a parameter. So you can use that. And another hint on this, again, I don't know if I described this here, but so a lot of people, to create the model, the fitted model, will use the whole input data or the test data. So what you're actually doing is calculating the predictions for lots and lots of points there. And that works fine if everything's on a line. But when we get to nonlinear models, there can be problems if the points are in a particular order, because it'll be applied. So it's really better to just pick like an x of the minimum. So find the minimum and the maximum, or just, you don't have to go that far if you don't want to. So we know that the scatter plot data for the temperature is going from 0 to about 25 Celsius. So you can just create an array with x of 0 and x of 25, and use your slope and intercept to find out 2 points that would define a line. That's cleaner, especially for a linear model. When you have a nonlinear model, you would have to plot multiple points, but in that case, you really should create a array of x points. So you shouldn't be using your data, but have like a linear spaced array over the range you need of an appropriate amount of space between the points. I'll talk more about that, but that's kind of some hints on there in case I didn't go into some details on what we're looking for there. So there's other way. I would read. I mean, you could just use like Seaborn Library that has a function that will plot. So you wouldn't even have to do the linear regression using scikit-learn by hand. It would plot a visualization of the best fit ordinary least squares line. But yeah, don't do that, even though I probably didn't explicitly say that in the assignment. So I really want you to, fit the linear regression using scikit-learn, and then also plot the resulting model from the parameters that you got from your fit, at least to begin to understand what we're doing here. And again, we're kind of jumping ahead of here a little bit. So if some of the stuff is unfamiliar, we're going to get into the details of linear regression starting next week in our next assignment. So we're actually implementing the optimization to do this kind of linear regression. So these things will make a lot more sense. What we mean by these parameters, how linear regression figures out what the best slope and intercept, or the best slope and coefficients are for a set of data. This kind of stuff. So the last thing that we kind of talked about on Tuesday was the looking at the stats model. So I won't go over that again, but let me know if anybody had a question about that. So I did ask you to also use the stats model library. That should be imported for you on the assignment. So I don't know if I've mentioned the imports before. So usually not necessarily everything you need will be given to you on imports. But yeah, for one thing, you shouldn't be like doing like you shouldn't be adding new libraries other than the ones giving in the base reference in these dev containers. So you shouldn't be doing an apt install of new packages or a conda install or doing like a pip install to get stuff. I mean, you can add if there's something that you want to use, but you don't have it in the assignment library. So if you're using not sklearn or matplotlib, but something else that doesn't seem to be given to you, you should definitely ask me about it. But yeah, you should try and restrict yourself to the packages that are given for the assignment. So kind of as a reminder of that, that's basically what the environment file. So that is specifying exactly the packages that should be being used for these assignments. Class example. So yeah, I mean, so we are importing the stats model for you to use for, so you do need to also fit a linear model using stats model, the way we showed. We do reverse the line x for the function. You're supposed to write it the same way the stats model reverses those when you create the model in the stats model. So to be aware of that. Okay, so let me talk a little bit then about doing the classification, and then if I have time, I might go back and also look at our textbook materials about from this chapter 3, doing classification. So we do ask you to do a binary classification task. So if you did the readings for this week, you should understand what that means. So in this particular data set, we do have one feature, which is whether it rained or not. The next day. Yeah, the initial tasks on this are to actually encode it as a category, as a binary category feature, so that we can use it as the target for a binary classification. So So you probably need to be careful here. You do the way it's suggested to encode this using like an ordinal encoder from scikit-learn or something. It can just arbitrarily, because these are just strings like yes and no that we're trying to encode as an integer number here. So we're not doing one-hot encoding in this assignment. We're just going to do an ordinal, which is an integer encoding here. But you might, I think you do, or else it might flip it around. So by convention for binary classification, 0 is usually meant to be the negative class, the no class, and 1 the positive class. So you want to ensure that you end up with 0 associated for no's encoded as 0 and yeses is 1. So when you create the ordinal encoder, you have to specify something like that, and then double check that that was the encoding that you got. This here. But yeah, I mean, that's going to be your Y. That's going to be your target encoding here for the second part. So, oh, right, and right, there's so one of the functions is supposed to be the label encoding function in the assignment tasks is meant to do that. Another reminder, so I think that we did give you the function documentation, so make certain you're keeping that and putting your implementations the correct place. Sometime in the future, I might ask you to write your PyDoc documentation. So this format, if I didn't mention, I mean, this is basically should be the same as the NumPy kind of style. They give like something like this, where you're supposed to specify the parameters, and return, where you specify the return values. There's another type of testing. This is also an aside. These doc tests, but admittedly, these I should check these or maybe remove these because these might be a bit out of date. We were using this before on some of these assignments, doc tests instead of the unit tests. So I can't guarantee that these doc tests are up to date here and working. So yeah, for 2, there is a little bit of data cleaning. So there's the label encoder where you're supposed to have given a Python data frame. Right? So it's not clear you are passing the Python data frame. It's just expecting the particular column. So you'll probably have to extract out the particular column, but it should still be a data frame or series, pandas, that comes in here. And we're expecting to do an orbital encoding, so return it, but also return some information about it. So basically, if I haven't mentioned this before, so these functions aren't kind of realistic of how you would actually do these in a real project. We do stuff like this where we return a bunch of information just to make it easier that I can test your work on your assignments. So this kind of stuff. We generate like random data that we pass in here, and we check that the number of dimensions and the number of no's and yeses are correct for a set of data. So I was going to look up the test for that one as well. So at some point, in order to do some of these things, you'll have to become comfortable also kind of reading and understanding what the tests are doing. Right? So basically, your functions, like this label encoding I'm looking at right now, are going to be tested inside of the test assignment tasks in something. I mean, it should always be in this form: tests and then the name of the function, test underscore whatever function. So, so forget the reason why I was bringing this up. I couldn't remember, but we're expecting actually it to be a NumPy array. So we're not. So when you do an orbital encoding, it shouldn't end up as like a pandas series or a pandas data frame. It should end up as just a NumPy array. Get back from there. That's basically what this is saying here. That so if we run your function. The y would be NumPy in-dimensional array. And then here's where we're getting the other stuff. So all the other stuff, we just have. So here, we only tested it. So sometimes we do more extensive testing. We're only testing it on one set of input data here. So for that particular set of data, when you run code, we're expecting that it should end up with 366 values in y. And 300 nodes, 66 yes. So again, if you don't associate 0 with the no and 1 with the yes, you won't get the correct values, or you'd have those flipped potentially. Okay, and there is, after the label encoding, then a function for computing missing data. In this one, we are using multiple features, so we're using 2 features instead of 1. to do the categorization for the second task here. And it turns out that one or both of those have a few of them that are missing. So this one, read the examples about using scikit-learn to fill in missing values. So yeah, we just ask, figure out what the mean is, and so I can't remember if it was both features had some missing. If it was just one of them had some missing values. The two features we're using for the categorization example task in the second part. Okay, and then so I wanted to discuss this to make sure everybody's kind of understands what we're asking for here. So I already kind of started this up here. So again, if you follow what's described here, you don't necessarily have to understand yet what the details of how a linear or logistic regression work. But yeah, in this case, we want to visualize the decision boundary. So you should end up with basically that. That should be the resulting visualization if you use logistic regression from scikit-learn as is asked for here. In this case, we end up with, so we have actually two features. So sunshine will be theta 1 and pressure will be theta 2. So this notation, or actually, theta 0 and theta 1. So from scikit-learn, or we'll be using this theta notation here. But if it's not clear, the coefficients, so again, when you do the logistic regression here, you'll have an intercept term and you'll have two coefficients. So since we're fitting a model with two features, you end up with two coefficients. The first one, the one at index 0, should be the one that's associated with what we're using as sunshine. And the second one, the one at index 1, would be the one associated with the pressure. But yeah, those decision boundaries basically just this formula, right? So the two coefficients and the slope. So in order to do the visualization of the line, again, you kind of have to remember back to algebra or geometry that you might have done, equations of lines or things like that. So basically that decision boundary is going to be where this goes from negative to positive, or so 0 is going to be the dividing line between where we predict one class or predict the other class. So that's why we set this to 0 and rearrange for y. That'll allow you then again to fit in. So if you want to visualize this, once you rearrange, you can just figure out for 2 points, like for 0 and 14 on the x-axis to figure out the decision boundary, the dividing line between the two categories. This was discussed a little bit in your readings for this week, the idea of a decision boundary. So when you're doing a linear model like this, so this logistic regression is also a type of linear model. So it computes a linear decision boundary that ends up being a line if we have 2 dimensions, or a hyperplane if we have a plane or a hyperplane with 3 or more dimensions there. But it's going to be a line or a plane, basically a linear. But so what's happening with the decision boundary is if I ask for a point who's, that ends up over here, let's say. So sunshine of 13 and pressure of 1,025. So anything on this side of the decision boundary, we're going to guess 1, or we're going to predict 1, but yes, it will bring. Anything that would be on this side of the decision boundary will end up with a prediction of 0. For a binary classifier. And again, there is some sense, so this is what we're going to start discussing next week or the week after. There's some sense of this is the best decision boundary you can make given this linear decision boundary you can make given this data. So we'll minimize the error that we will define. Fit our decision boundary. We can see, I mean, there's going to be no perfect linear model here. Right? There's no line that exactly separates the yeses and the no's. So if you want to do better than this, we have to use some sort of a nonlinear model, something that we can have, or add in additional features so that even if it's not separable on these 2 features, if we add some additional ones in higher dimensions, it might be that these are more linearly separable, more easily able to have a decision boundary that does better at separating and predicting yes or no. Yeah.
So below the decision boundary, that's 0, and above it's 1.
This is basically where what happens is for a classifier. So if I pass in like a sunshine of 13 and a pressure of 1025, I'm basically passing in 13 and 1025 and multiplying those by the coefficients and adding in the intercept. So the result is going to be some real value number, positive, 0, and negative. Anything positive. So everything above here, when you put that in here for a binary classification, is going to be a number greater than 0. This line is going to be exactly 0. So we have to, when we make a final prediction for a classifier, for like a binary classifier, we have to return yes or no. So we have to return true or false, yes or no in this case. So the usual convention is when you fit a model like that, anything that's positive will get returned as yes. So when you plug it into the numbers here, if it's greater than or equal to 0, not allowed stuff to be exactly on 0. If it's greater than or equal to 0, we would predict yes, and if it's negative, less than 0, we would predict no. So, yeah, there is a relationship, right? So, I mean, this, when you plug this in here, we are going to get a result, but then when we have to make our final decision, we usually conventionally use 0 as the dividing. So this was talking a little bit about chapter 4. I don't know if I have some time to go into that. So you can, when it was talking about precision and recall, you can actually, once you fit a model for set data, you can change your decision boundary. To maybe above or below 1, above or below -1, and get and change your balance of the precision and the recall. And that's what that whole discussion of precision and recall was about. You're really, instead of using 0, you're using a slightly different cutoff point for your decision boundary. Right? But that kind of stuff, you usually do that kind of after. So after you fit the model, you might want to then move that around in order to emphasize either not having false positives or not having false negatives. Okay. But yeah, since I'm talking about that, well, let me finish up here. But maybe I could jump for 5 or 10 minutes and look at the classifier material that we had here. So anyway, for that, I mean, after you get the scikit-learn, you are also asked to also um, fit a stats model using a logistic regression. So instead of the OLS object, ordinary least squares, you'll need to use the appropriate object. So there's an example of that. So in the lecture notebook on using scikit-learn stats model, I can't remember what the name of the object. So instead of OLS, you have to use the other object in stats model for doing logistic regressions instead of linear regressions. But it should pretty much so if you've got the stats model working, this should work here, although you also need to add in the dummy constant inside of this function. So before you fit the stats model, it doesn't by default provide an intercept term, so you need to add that in and do the summary. Logistic regression using stats models. Okay, and I might give a few extra credit points here. You can, I think if I remember, you can't improve the performance a whole lot, but you can get a little bit of improvement by adding in a few other features, right? So up to this point, you're asked to create a classifier just using the two specific features, but if you try it, this feature is more highly correlated than the two that we asked you to use, so you should see a little bit of an improvement. I believe if you add that in, maybe try adding some others as well. So, if you have any questions, let me know. Let me just jump to real quickly materials for this week, since I was talking a little bit about the precision and recall. So, and we can talk more about this later if people want some more discussion of it. But yeah, just since I only have like 2 more minutes or so, just a couple of points about classification. So the measuring the accuracy, measuring the performance of how well a classifier is doing is a little bit more difficult than for regressions. For regression, if I predict the house price is $1 million and the actual price is $1.2 million, you know that you have an error of $200,000. So errors make a little bit more sense. For binary classification, I mean, the how well you're doing. I mean, there's a straightforward answer to that, right? So if I have a classifier for binary classification, if I make a prediction that the result should be true and it's false, I had a misprediction, right? So an easy measure of performance for a binary classifier is just the accuracy. But accuracy so like when you get to multi-class classification, so if I have more than 2 categories, what does it mean if you guess wrong? Is it better if you were closer to the right answer or So you have questions like that. So, but anyway, I mean, most of the stuff, if you read the chapter here, looking at the performance measure, was discussing kind of these issues. Right? So a little bit of a better idea, especially if we're doing like a multi-classification. So if I have more than 2 classes, is to you might want to start by looking at the confusion matrix. So the confusion matrix is just so this for binary classification, you can think of the confusion matrix like this, and this will give you also break things up into false negatives and false positives, and my correct answers, true negatives and true positives. So by convention, when you display a confusion matrix, the rows should be the labels. So it should be the actual results. And the column should be the predictions that your model is currently. And then you can just count up. So every place where it was actually false, if we're just doing binary classification, and we predicted correctly, those are your true negatives. Right? So the diagonal, if we have more than 2 classes, is always going to be your correct one, where my prediction was the same as what the label was. And then the off diagonals are going to be where you mispredicted. But the point is for classification, false negatives and false positives mean different things. And in some, so in some contexts, it's more problematic to have false negatives. In other contexts, it's more positive to have false positives. Right? So the example I usually give is so if you're making a predictor in medical imaging, whether this medical image, we're going to predict that they have cancer or don't have cancer. So a false positive is going to be where they don't have cancer, but we predicted they did. So in that case, for false positives, the downside is more tests, so maybe wasting money. So it looks like they have cancer, we might have to do more expensive tests to see whether it's true or not. Or I guess in the very worst case, we could start giving them treatments that they don't really need. But that can be definitely not as worse as false negatives. So in the context of making predictions for medical, if they have cancer and we don't predict, I mean, they could potentially die from not being treated early enough. So in those types of situations, you might want to change your decision boundary, which will lower false negatives, but at the expense of you'll have more false positives. That's kind of all the time that I really have here, but that's really what the precision and recall trade-offs are. These are measuring different ratios of true positives to false positives. So that's precision. So this is going to give you some information about false positives, and it's going to give you some recalls, going to give you some information about false negatives. And if it wasn't clear when you did the readings, basically that's what's happening here. Is so the default threshold is usually 0 for a binary classification, but if we calculate precision and recall, we can move that. So the result will be to precision and recall, or false negatives and false positives, are always going to be the word I'm looking for, that it's always going to be a trade-off. So I can make false positives less, but whenever I do that, it's going to always cause false negatives to become greater, or vice versa. And sliding your decision threshold allows you to do that. In some applications, then, once you build a particular model, then you might want to tweak I need to emphasize false positives or false negatives based on my application. Change the threshold so that we're ensuring we're getting less of one at the cost of getting more of the other. So I just mentioned that because I did ask you to do like a confusion matrix and plot the precision recall as well. So there's some examples of doing that in here, kind of by hand. But you can use the same examples. There's some higher level functions for doing precision recall curves or these ROC curves. These give you, this is another way of doing a similar kind of thing. So these are also giving you some idea of false positives, false positives, true positives. Okay, so let me go ahead and we'll stop there. So I think I hit most all the stuff I wanted to today. I'll let you go. Let me know if anybody has questions. Make sure you get the assignment 2 in by Friday.